Last Saturday, a computer solved 10 problems that nobody had been able to solve. And the mathematicians who care most about those problems did not say the thing you would expect. They did not say, "I am out of a job." One of them had already written down what he was actually afraid of. He wrote it 6 days before the announcement, and there is not a single piece of mathematics in the sentence. I want to tell you what he wrote, because I think it describes something that is happening to the rest of us too. Not on the scale of a whole field, on the scale of about 10 seconds. Here's what happened, plainly. On August 1st, 2026, OpenAI announced that an internal version of its next model, called Astra, had solved or made substantial progress on 10 open problems. They were spread across 8 areas of mathematics and theoretical computer science. Every one of them had been open for at least 10 years, most of them much longer. One was abound on how tightly spheres can be packed in high dimensions, a record that had stood since 1978. One settled a question that had been sitting there since 1999. 3 came from a famous catalog of unsolved problems left behind by the mathematician Paul Erdos. And the company did something unusual with the proofs. It published a 249-page manuscript, and alongside it, machine-checkable certificates in a system called Lean. Lean does not care who you are. It checks every step. In that system, there is a placeholder you write when you want to skip a step you have not filled in yet. The count of those placeholders in the repository is 0. 2 honest notes, because they matter. Not all 10 were clean solutions. Some were substantial progress. An OpenAI staff helped prepare the papers and formalize the arguments. The company says the mathematical content came from the model. So the results are real, and they are checkable. That is not the part I want to talk about. What I want to talk about is the reaction. Because the people closest to this did not respond the way the headlines did. And when I read what they actually said, I recognized it, not as a mathematician. I am not one. I recognized it as something much smaller and much more ordinary, that happens at my desk most days. So here is what today is, what they think is being lost, why it is not the answers, and one thing you can do about it tonight that takes about 10 minutes. 6 days before the Astra announcement, Timothy Gowers wrote a blog post. Gowers won the Fields Medal, which is roughly the highest honor in mathematics. He was writing about what happens to his field if machines get very good at this. And he did not write about jobs, or funding, or prestige. He wrote this: after a decade or two, we might arrive at a situation where the mathematical literature has, in some form, been vastly expanded, but there is no corresponding community of human experts who have a shared understanding of parts of it. Sit with what that actually describes. The knowledge is still there. It is on the shelf. It is correct, it is checked, and there is more of it than ever. What is missing is people who understand it. A library that nobody can read is not a library, it is a warehouse. And notice what he is not saying. He is not saying the machines will get it wrong. He is assuming they get it right. The problem he is pointing at only exists if the answers are good. Here is the part that changed how I think about this. That exact thing has already happened once, and it was not caused by a computer. It was caused by one man, and he wrote about it himself, with what sounds to me like real regret. In 1994, William Thurston published an essay called On Proof and Progress in Mathematics. Thurston was one of the great geometers of the 20th century. In the early 1970s, he worked on an area called foliations, and he was extraordinarily good at it. He proved the main theorems. He proved them fast. And this is what he describes happening next. He started hearing that mathematicians were giving each other advice not to go into foliations. The reason given was that Thurston was cleaning it out. People told him, and he says they meant it as a compliment, that he was killing the field. Graduate students stopped studying it. Before long, he moved on to other things himself. Now here is the sentence that matters most in this whole video. Thurston says he does not think the field emptied out because it had been intellectually exhausted. There were still plenty of interesting questions left. Many of them, he thought, were probably within reach. The problems were still there. The people left anyway. So what got taken? Not the questions. The questions were sitting right where they had always been, and Thurston says so. What got taken was the reason to go in. A field stays alive because somebody is willing to be stuck inside it for years. That is the entry fee, and it is also the thing that turns a person into someone who understands that field. When the answers arrive fast enough, the fee stops looking worth paying, and then quietly, nobody pays it. Gowers is describing the same shape at a much larger scale. The literature grows. The community that understands it does not. Now I want to bring this down to a size that fits inside a normal day, because I do not think this is only a mathematics story. Think about the last time you did not know something. Not a big thing, a small thing, something at work you had not seen before. A bit of code, a clause in a contract, a line on a bill, a decision you had to make with information you did not have. There is a gap between the moment you notice you do not know and the moment you ask. For most of human history, that gap was long, because there was often nobody to ask. Then it got shorter. Now, for a lot of us, it is about 10 seconds, sometimes less. I want to be careful here, because I do exactly the same thing. My hands are usually on the keyboard before I have finished reading the question. I am not describing a flaw I have spotted in you. I am describing a change in what is available, and it changed for all of us at the same time. But I've started to wonder what used to happen inside those 10 seconds. It turns out that has been measured, and it was measured long before any of this. In 2011, 3 researchers, Betsy Sparrow, Jenny Liu, and Daniel Wegner, published 4 experiments in the journal Science. The finding is now known as the Google effect. When people expect that they will be able to look something up later, they remember less of the thing itself and more about where to find it. Their memory does not get worse. It reallocates. It stops storing the content and starts storing the address. And I want to say clearly that this is not a tragedy. It is a sensible trade. You do not need to carry a trained timetable around in your head. A brain that treats the internet as an extra drawer is not broken. It is efficient. But notice what the trade is made of. You are exchanging the content for the address, which is fine, right up until the moment you wanted to be someone who knows the content. Here is the second piece, and this one is older and stranger. In 1978, 2 psychologists, Norman Slamecka and Peter Graf, ran 5 experiments with 96 students. The setup was almost absurdly simple. Everyone saw pairs of words. Half the time you were shown both words. Half the time you were shown the first word, the first letter of the second, and a rule, and you had to produce the second word yourself. Same words, same amount of time. The only difference was who produced them. The people who produced the words themselves remembered them better. In all 5 experiments, across every rule they tried, across different pacing, across every way of testing it. This is called the generation effect, and it has held up. A later analysis pooling 86 studies found an average effect size of about 0.4. In plain language, that is not a rounding error, and it is not a miracle either. It is a real repeatable advantage that comes from nothing except who generated the answer. Which is a strange thing to sit with. The answer can be identical, word for word identical, and it will still behave differently inside your head, depending on where it came from. Third piece. This one explains why the trade is so hard to notice while you are making it. In 1994, a psychologist called Robert Bjork introduced a term I think about constantly: desirable difficulties. His argument is that we consistently confuse 2 different things. There is performance, which is how well you can do something right now while the material is in front of you. And there is learning, which is whether you can still do it later, somewhere else, without the material. And here's the uncomfortable part. Conditions that make training feel smooth often produce good performance and poor learning. Conditions that make training feel harder, spacing it out, mixing things up, making yourself retrieve something instead of rereading it, often feel worse in the moment and produce better learning. So the feeling of it going smoothly is not evidence. It is not evidence that it went well, and it is not evidence that anything stayed. I do not know a better description of what it feels like to work with a good model. It feels smooth. It feels like the friction is finally gone. That feeling is exactly the one Bjork spent a career telling us not to trust as a measure of learning. One more, and this one is recent. In 2025, researchers at Microsoft Research and Carnegie Mellon surveyed 319 knowledge workers about 936 real uses of generative AI at work. I should say plainly that this is a self-report survey, people describing their own experience, not a controlled experiment, so hold it loosely. But one pattern in it is worth hearing. The more confidence people had in the AI, the less critical thinking they reported doing. And the more confidence people had in their own ability, the more critical thinking they reported doing. Put those 2 together. The tool was the same. What moved was whether the person believed they had anything of their own to bring. So we are all holding a trade that is very badly timed. The thing you gain, you get immediately. Right now. Today. The answer, correct, formatted, finished. The thing you lose, you find out about in about 3 years, in a conversation where you needed to actually understand it, and you discover that what you kept was the address and not the content. And nothing anywhere makes a record of which trade you just made. No line item, no notification, no total at the bottom. There is a line that gets quoted a lot from Epictetus, from the Discourses, Book 1, Chapter 24. It goes, "It is difficulties that show what men are." That line usually gets used to argue that suffering is good for you. I do not think that is what it says, and I would not say it to you anyway. Nobody needs more difficulty for its own sake. Life supplies plenty. Read it as a claim about information instead. His point is that difficulty is where you find out what you currently are. It is the place the answer shows up. Smooth conditions tell you almost nothing about yourself, because in smooth conditions everybody looks the same, which gives the whole thing an odd shape. If the hard parts get removed one at a time, and each removal is individually a good idea, then slowly you run out of places to find out who you are, not through any decision anyone made, just through a long series of small conveniences that were each, on their own, correct. Now here's the part I would want somebody to say to me, so I'm going to say it. Most of the time you should just ask. I mean that. When the Wi-Fi is broken, ask. When you need a document formatted, ask. When you are dealing with a field you will never work in again, and you just need the answer, ask, and do not feel anything about it. Skipping the struggle there is pure profit. There is nothing in those 10 seconds worth keeping. Being stuck is not virtuous. It is not a moral achievement. Most of the stuck time in a human life has been wasted time, and getting some of it back is one of the genuinely good things that has happened to us. The whole thing turns on one question, and it is a question only you can answer. Is this a thing I want to be able to do, or a thing I want to have done? Because those are different, and almost nothing in your day is built to tell them apart. Your calendar does not know. Your inbox does not know. The tool certainly does not know. It answers both kinds of question at exactly the same speed, in exactly the same tone of voice. That is not a failure of yours. It is just a distinction that nobody has built yet. So here's the small version. It takes about 10 minutes and you can do it tonight. Pick one thing. One. Not a policy for your whole life. Not a rule about AI in general. Just one subject where you would like, at some point, to be a person who actually understands it. For that one thing, do this. Before you ask, write down your current answer, in words, even if you are fairly sure it is wrong. And I want to be specific about why it is writing and not thinking, because that part matters. Slamecka Graf did not find an advantage for people who thought harder about the word. They found it for people who produced the word. You have to actually make something. A sentence you would be embarrassed to show anyone is enough. It just has to leave your head and land somewhere. Then ask, read the real answer, and look at the gap between what you wrote and what came back. Because that gap is the only part of this that will still be with you next year. Being wrong first is not a punishment. It is better than being blank first. A wrong answer is a hook, and the correction hangs on it. A blank has nothing to hang on. And if you find you did not actually want to be a person who understands that particular thing, that is a completely acceptable answer. Ask, take it, move on. You just made the trade on purpose instead of by default. That is the entire skill. I said at the start that the mathematicians were not afraid of the 10 problems. I think that is right. Nobody is mourning 10 proofs that now exist and did not exist before. That part is straightforwardly good. What Gowers described and what Thurston watched happen to a field he loved is quieter than that. It is a decade from now, all the proofs still on the shelf, every one of them correct, and nobody left who has ever been inside them. That will not happen to you at the scale of an entire field. It does not arrive as an event. It happens 10 seconds at a time, and every single one of those 10 seconds is, on its own, not worth defending. So do not defend all of them. Defend one. Because the answer can be word for word identical, and it will still matter who produced it. That is not a moral. That is just how memory works. Good night.